Right, folks, here's a question from a student. This is question number 26 in the Permutations and Combinations assignment. So in this question here, we have 10 students that have been elected to serve on Students' Council. In how many ways can 4 of these students be chosen to represent the school as ambassadors at the Provincial Education Conference? So we're selecting 4 individuals. The order in which we select them doesn't matter, right? So anytime order does not matter, order does not matter. Anytime order doesn't matter, it will be a combination problem. Okay, so we will be using the C notation. We have a total of 10 students, so in how many ways can we choose 4 students out of 10? That's going to be 10, choose 4. And if we run that through our calculator, we're going to get 210 different ways that we can put that council together. In B, in how many ways can a president, vice president, secretary, and treasurer be chosen from these 10 students? Now, here order matters. The first person we select is going to be the president. The second person we select is going to be the vice president. The third person we select is the secretary, and the fourth one will be the treasurer. So this is a situation where the order matters. Okay, so if you have say a committee where everybody is equal, then the order wouldn't matter. So that was basically what we had in question A here. We had a group of people, we just needed 4, everybody is equal. Here, we're selecting 4 people, but they're not all equal. The first person is the president, the second person is the vice president, etc. So the order matters. So in this situation here, order matters, which means it's a permutation problem. Okay, so we're going to use the P notation here. So we're going to say that we're going to say 10 P4, which is 5,040. And in general, anytime order matters, we would have more arrangements. You can very clearly see here, we would have more arrangements than if order doesn't matter. And finally, in the last question here, 6 of the 10 students elected to student council are girls. In how many different orders can 4 of the students line up for a photograph if there must be an equal number of boys and girls in the photograph? Okay, so the scenario we're talking about, we're going to have students lining up, and 2 of them will be girls, 2 of them will be boys. So the scenario is 2 girls and 2 boys. Okay, so just to choose 2 girls from this from the 6 girls, that's a combination problem because each girl is equal, right? The fact that you would be the first girl being chosen or the second girl being chosen has no effect. They have the same sort of status, right? So here we would say it would be 6 choose 2. It's a combination problem, and means multiplication. And the same thing goes with boys. Doesn't matter in which order we choose them. We're just choosing 2 boys. How many ways can we do that? It will be 4. There are 4 boys, right? There were 10 students. 6 of them are girls. That means there are 4 boys. 4, choose 2. Okay, so this here, so if we calculate this, so 6 choose 2 is 15 times 4 choose 2 is 6. 15 times 6 is 90. So this here is going to be the number of ways of choosing 2 boys and 2 girls from this group of boys and girls. So number of ways 2 boys and 2 girls. But there's a little bit more to this question. If we go back to the question and read it carefully, it says, in how many different orders can 4 of the students line up for a photograph, etc., etc. So here they're talking about the order. So far it's been a combination problem, right? Because it doesn't matter in which order we choose the girls or in which order we choose the boys. So there are 90 different ways we can choose 2 boys and girls. Now we need to decide, once we have those 4 students, in how many different arrangements can they line up? Okay, so this is going to be just 4 factorial. Or you can also use the fundamental counting principle, right? Which will lead you to the 4 factorial. So it's going to be times 4 factorial, right? And this is because this will tell us the number of ways we can order 4 people in the photograph. Okay, so the number of ways we can order 4 people in the photograph. So if we calculate this, so 4 factorial is 4 times 3 is 12, is 24. So it's going to be 90 times 24. And this is 2,160, I believe. 2,160. Okay, so this is a bit of a tricky problem because we are combining combinations and permutations. Okay, I hope that helps. Until next time, see ya.